to re-enable. Yeah, perfect. I go next. And well, the status of MLDCAT-AP. Yeah, I think maybe I would like to give, before the status, to give the word to Natasha. Natasha, over here, just 1 minute to talk about SEMIC and what we are doing here, probably.
Hi, so thank you all for joining. Yes, as Emilio said, this is the MLDCAT-AP dedicated webinar here in SEMIC. We are probably, since you all are here in this webinar, you know that SEMIC is the semantic interoperability community, so we are trying to facilitate member states, but not only member states, various other stakeholders with exchanging their data and addressing semantic interoperability. We are having a set of assets, of semantic assets that we are promoting, and we are trying to keep up to date and always cater for the needs of our stakeholders. And we are also doing pilots when we see an opportunity, and we are trying to enrich our specifications with new metadata needs. I won't get into the details of the assets that we are maintaining in SEMIC. Probably you know that we have the core vocabularies and the DCAT-AP and the different extensions of DCAT-AP related to the needs and the different domains. Here today we are discussing about MLDCAT-AP, which is a new addition in our inventory, relatively new because we are working on MLDCAT-AP for the last couple of years. I won't say much about it. I will leave the rest to Emilio to update you about the status, the challenges, and what is the current situation. Thank you all for joining.
But indeed, coming on the data exchange, on one end we have machine learning model providers, I would say, that use platforms to publish their models. And on the other hand, we have users that need to find them their model. They would like to use it or reuse it, let's say, in a way, making sure that they can be usable. So there is some expectation on both sides, transparency, but also quality. And that is on something that platform, let's say, allow as a distribution channels, I would say. On the other hand, we have the AI Act that already was published in 2024, July 2024, and it's already, let's say, part of the obligations for machine learning providers are already in, let's say, in force as August 2025. So it means that we need to act on one end as a platform, but in order to make sure that provider and users have their own guarantees on what they found. Going indeed to MLDCAT-AP, we started the MLDCAT-AP in beginning of 2023. At the time, the version 1.0.0 was created in collaboration with the OpenML. It was indeed starting as a pilot, not as an intention to create a really a data model, but from there, let's say we understood that there were problems of interoperability. So describing the models, let's say the machine model, all the process was something that required some analysis. At the same time, we started to introduce DCAT-AP because DCAT-AP allows us already in Europe to describe data sets. So all the metadata concerning the dataset and their distributions were indeed useful to describe the dataset on which machine learning models are executed or trained on. And over the year, let's say we moved to MLDCAT-AP 2.0.0 to 1.0 and now the 3.0.0 by adding on one end new classes that are coming from the AI Act and let's say even mostly the AI Act, but then we will see other policy documents. And also doing comparative analysis, extending such analysis basically to other repository machine learning models. So we've been analyzing, for example, over time, Hugging Face or other repository that require indeed a certain data structure in order to represent their machine learning model. So the latest version, which we would like to publish in September 2025, is MLDCAT-AP 3.0. From this version onward, we would like to align with DCAT-AP, let's say, version. So in this case, DCAT-AP reached version 3, the major version, I would say, of DCAT-AP. So DCAT-AP 3.0.1 is the latest major, let's say, version of DCAT-AP. So therefore, MLDCAT-AP version will be 3 something, let's say 3.0.0 in this case. So at least the major version are aligned, because indeed for us it's really important that the two are aligned in order to make sure that we have both interoperability in a way from the top of the model, and on the other end from the model from MLDCAT-AP towards DCAT-AP. Indeed, thank you, Natasha. There is a GitHub repository where the specification is published, at least the old one, and then the new one will come soon. The new element, indeed, in the 3.0 is the addition of the elements from the AI code of practice, because it reached, which we monitor over time, and it reached, let's say, a final version. It is much more structured than the AI Act per se, because there are forms that, let's say, machine learning model provider has to fill in order to make sure that they describe accurately the machine learning model. So, in summary, what we see in MLDCAT 3.0, we have, from a legal perspective, the AI Act, that you see there on the left. From policy perspective, the AI Code of Practice. It's a policy still. It means it's not a legal document, binding document, but at least it's quite structured in order to be, let's say, to be used in our case for MLDCAT-AP. On the other hand, we have as a main data model DCAT-AP concerning datasets, etc., and some additions from other data model like MLS or LPWC or DPV that we've been starting using where needed for certain parts of the classes or properties. So that's the overall picture. I show you here some parts of the relevant annexes from the AI Act. The annexes are quite, let's say, they are quite, I would say, they provide some list of points that should be in the description of these models. For example, you see on the left the task that the model is intended to perform, or the policy applicable, or the date of release, or the method distribution of a model, or even the license. So while on the right-hand side, you see a part of the specification where we have the machine learning model properties. And indeed, for each property, you have also what kind of range of data type is about, its own cardinality, a definition, event optional usage node, and a reference. So now we start indeed adding the reference. You see on the right-hand side, some of them are coming from the AI Act, other from the AI Code of Practice. And so in this sense, we try to at least have some provenance and to say, okay, this information is required by this policy, or can be even reused, is used by, for example, by DCAT-AP, and then we will see later on. So in this case, for the AI Act, you see, for example, the license, the 1F there. There is a license property for the machine model, which is mapped to the license document, so there is another class associated with that. Or even for the policy, there is a as policy property, which is associated to a policy document into it. So we try to extract basically as much as possible information that are indeed coming from the annex of the AI Act. Same thing on the AI Code of Practice, that is indeed quite structured. You see that on the left, there are already properties with even also definitions per se, like the scope of the model, the data curation methodologies, or the provider have to describe, for example, the training time, the computation used for training, etc. So these are part of the model you see from a dataset. Yeah, I see. Thank you, Arsh. It will come also to that. We will come to this point into the issue later on. But I can already tell you, we started with literal from different reasons. Not only for say compatibility with the DKTP on one end, but also because at the beginning we want to be as flexible as possible. Then in certain parts can discuss later in the issues. There are parts that where we would like indeed to review certain parts there. So I will come back to that. So coming back to code of practice, indeed, certain parts of the code of practice can be indeed put into the dataset. For example, we see the bias method or the curation method. We have also the geographical coverage of the dataset, for example, which are also indeed associated, as you can see over on the right, the code of practice, but also on the DKTP. For example, in DKTP, the property geographical coverage or language already existing. So we use both reference here. So we say, okay, we reuse the DKTP, in this case, geographical coverage, because it's already there, which is good, but it's also coming from the AI code of practice as a requirement into it. The same for the execution, basically the run of the machine learning model training on a given task. So then you see certain properties that are indeed referenced, other not, because then they are used to, for example, linking to other type of part of the model. Over time, we would like to indeed improve this reference in any case, because for us it's a way to be driven to say, okay, this property must be there, at least for that reason. And then, as already mentioned, we have the DKTP 301, which was already published in July 2025. It's so the idea is indeed to be aligned with that. We have the class dataset, for example, one of them. It's the dataset class, which indeed is used for DKTP, but also for many properties that are coming from different properties that are coming from the AI Act or the code of practice. We have many of them indeed from dataset, but for example, data provenance, it's as a requirement that comes from the AI code of practice, or even its own description as well. So there are things that we reuse as is. That's why you have the A next to DKTP, because we reuse as is in order to guarantee as much as possible interoperability with DKTP 301. Then there are other things that are indeed coming as a legal or policy requirement and then we could eventually do even more refinement. For example, like Arsh was saying about literal, etc. And we can discuss later on this. I don't want to scare you with all the bigger diagram, but that is, I would like to give it just a helicopter view of this. In the middle in red, you have concepts that are reused by from DKTP. That is important. For example, when looking at a process in machine learning model, we have the data preparation. And so we need to, on one end, have data that are represented by, for example, data set and its own distribution, or included in a catalog. On the other hand, when you prepare data, you need also quality. And that's the group in blue that you have on the right. This quality, it's already, for example, already mentioned from the AI Act. And so there are a few classes that are concerning that. During such process, we need to choose also the learning algorithm. So the algorithm class is present in the let's say, lighter blue on the bottom. Still, to train a model, you will need also to define what your machine learning model, but also your infrastructure with hardware and libraries that you see on the bottom side. That is indeed related to, later on, you will need to evaluate what are basically the benchmark and the risk associated with the model. So again, this is the AI Act, and before you in the AI code of practice, I've mentioned this. And then finally generate prediction as the datasets that are output of your machine learning model class. So that is, let's say, an helicopter view of the MLDCAT-AP without really entering into the match. But what you see in this slide here are really the mandatory properties if we look from the machine learning model point of view class. Indeed, you see that for machine learning model, until now, you have 4 properties as mandatory: the title, an identifier, when was created, and its own version. And the relation towards a dataset, which is on which at least has been trained on, because to exist, a machine model should be trained on a certain dataset, which with its own collection date, description, title, and the file itself on the machine model, so with its own format, identifier, title, URL. So that's the really minimum set that you need for describing a machine learning model class. And all the other classes, yes, of course you can add them. When you add them, then there will be other, for example, mandatory or properties, but all the other classes are optional. So that's the minimum one to describe a machine learning model class. And then, yes, to support implementers of MLDCAT-AP, we've been creating, publishing a validator thanks to the ITB infrastructure. Until now, there is version 2.10, the one as soon we started validator from, and we are testing now the MLDCAT-AP 3.0 in order to make sure that indeed you can validate. At this URL, you can go the URL on the bottom, and so you can validate with an URL or with uploading a file and make sure that the file described according in RDF, because it's a semantic model here, it will be valid according to MLDCAT-AP then 2.0 or 3.0. So that's a tool that you have to play with and to make sure that you can pass validation. I think we are reaching the point here for the publication office to be in. As transition slide, what I want to say here, that in machine learning model, you can classify in 2 ways, via the type property that you see in orange here on the bottom, through a concept that can come from the AI taxonomy of the publication office, or via the modality class, which has been created by referencing from the AI code of practice, where you can specify what are the input or the output modalities and the maximum size for each of them. So mainly, I would say the type, because it's direct to the machine learning model, and then I'll give the floor to the publication office to explain the AI taxonomy. Thank you.
Yeah, thank you. I maybe Gabriele Pozzetti from DG2B1. I can probably give a very quick overview of this corporate taxonomy, but then leaving to the publication office for a better hands-on demo, if it's okay. And if I see how to share with WebEx, because I'm always, yeah, well, it should be working.
Yes, it's visible.
Great. Let's see if I can also move it. Great. Okay, so thank you for having us and to discuss about the corporate AI taxonomy for the Commission. So I would like to quickly give you an idea of why do we need a corporate AI taxonomy, as currently many taxonomies around AI are being developed, and many of those would actually be with wider scope. So why do we need a corporate one? And the main idea is that, well, AI is a field that is evolving very rapidly, as I'm sure everybody knows. And this also reflects on AI semantics in particular. We can see it from the amount of research that is being done on AI, and therefore the amount of development that would require new wording on update or other wordings that increasing significantly over time. But also, if we move from a research point of view to an actually very much applied contract disputing level, we know that semantics about AI is currently a key player on how very big contracts are being actually challenged. And one of example that was on the news for quite some time is indeed this negotiation between OpenAI and Microsoft around one specific terminology of AI and AGI in particular that will determine till how long, let's say, Microsoft can claim right on earnings. So for this reason, it's becoming fundamental to understand and have a common understanding across the full corporation of key terms about AI to make sure that we have a defined reference. So that's why the working group started his work to try to understand and make a evolving but still robust picture of the vocabulary need in terms of AI of the European Commission. And the main idea was to include the different directorate generals that are currently having systems that operate around this area and need semantics about AI to give a clear perspective of the current needs, so to put a point, and making a tool that can evolve during time as those needs are expected to evolve. The focus here, so what we are trying to achieve is really to get the minimal set of terminology around AI that we need to operate current systems, right? And then have a concept in place on how these can be covered by existing taxonomy or being, let's say, the fundamental basis for later interoperability. Is very difficult. Interoperability is one of the key concepts we are looking for in our information system. It's very difficult to achieve if we don't have a common vocabulary, if we're calling things differently. Right, so the way we went at that one was first phase of roundtable ideation of what are the different perspectives, because of course, within a big reality, many key players have different perspective on the specific issues and how a terminology should be organized. And since the beginning, we noticed that even to reach the first publishable version of a taxonomy, we needed to include an agile approach in which we iterate over and over to allow stakeholders to propose changes and refine the new versions. And so that's how we started implementing this search for the first. And this comes quite at handy because we know, as we said, that this taxonomy will change over time. And therefore, we already have the process in place to securely update these resources. And finally, this iteration was tested against specific stakeholders through bilateral meetings, so that they could change, they could challenge, let's say, the current status and propose improvement. Currently, this first iteration, first public iteration, have been prepared and approved by the working group, and is being implemented in the tool that will allow it to be sustained on the longer time in terms of update changes and make it available for specific stakeholders that want to use it. And once finalized, the last polishing and the last approval, it will also be sought to be available as a vocabulary. To give you a hands-on demo of what's the current status of this minimal version of the taxonomy that we achieved, I think I will give back then the floor, Aniko, to the publication office that is curating as all the technical aspect of how to make this taxonomy available for the different DGs that will take.
Thank you very much, Gabriele. And I started sharing the screen. I hope you all can see it.
Yes.
So this is going to be just a short hands-on demo of how the AI taxonomy has been structured now after all this work that Gabriele has explained. So as you see here, now this is pre-published. So this is just a preliminary version that has been published on ShowVoc, which is similar tool to Workbench. Workbench is the tool where we maintain the taxonomy, and then ShowVoc is where we do the first preface of publication, and then the final version has already been stated will be on EU vocabularies. So these are the three platforms where the taxonomy is accessible. For ShowVoc is a very easy tool to visualize and explore the data, the semantic assets. As you can see, the taxonomy has three top concepts now. So it means that three main groups of concepts that can be browsed in a hierarchical way. The first covers the artificial intelligence approaches. So this covers really the theoretical and the perspective point of view of the concepts. For example, generative AI or knowledge-based AI, you can see here all the models and large language models, for example, that have been covered in this group of concepts. Then artificial intelligence systems is the next big group, which covers the expert systems, reasoning systems, robotic process automations, and so on. So this is really on the system level. And then finally, machine learning, which is, of course, a very big group of AI-related concepts as well, covering deep learning, supervised learning, and so on. So it can be further extended in the hierarchical way. And if you select one concept, then you can open all the details that it currently has. The preferred label that is currently only available in English, but once it's published, it can be also enriched with translations if it's necessary. So normally the system, of course, allows the multilingual features as well. Then very important point is the definition, because the working group made a big conceptual work also on the definition of each concept. We took into account the existing ones from other similar vocabularies that also cover this particular concept. For example, the European Science vocabulary, EuroSciVoc, or Eurovoc, or the Digital Europa Thesaurus. So there were several other assets that were investigated. And here you can see the final definition and also the source of the definition. And what is also very important is that the tools all support the linked data features, so they can be aligned with other vocabularies. And if this vocabulary is available also in the same tool in ShowVoc, you can just directly click on the link and open it. Therefore, you can explore the other language variants, the other definitions, and all the other details, for example, other hierarchical details that the other taxonomy has. So it really supports also the visualization of these features. That was a very short demo for that, but actually the link, I will put it to the chat so everyone can explore, because it's already public. And for any eventual questions, we are here to reply.
Thank you, Gabriele. Thank you, Nico. Indeed, if there are questions, don't hesitate even to write in the chat. Then we can still look them back later on eventually. I see a question for MLDCAT-AP from Irina. William, please. William.
No, I think I just wanted to give a sign that it was a very good presentation. So maybe I touched the wrong button in.
No problem. Just to reply to Irina, I would say we are not in contact with them with the tripod, but we will look into it for the future. Thank you. Arsh, would you like to put office eventually?
Hello, do you want me to ask the question by voice?
Yeah.
Yeah,
yes,
of course.
We can hear you. Yeah.
Perfect. I'll also turn on my camera. Hello, Thank you for this work. It is very interesting to see this being developed by the publications office. So my question is, this is clearly a very good tool to help enforcement as well as organizational documentation. And one of the big components of the Act is proposed uses, so as intended uses or purposes associated with it. Does the publications office or this project also envision a similar taxonomy?
From model perspective, I can tell you until now, we didn't think about it in terms of model perspective. From the publication office, I don't know, maybe that could be, it's something that you can look at it.
Willem, I don't know, because the question was related also to CRDM. Currently, I don't know any plans on that, but maybe we can take it on board if there is a need, of course. Yeah, so we can support.
I think that was indeed the way we worked was really looking at the use cases and the needs expressed by the stakeholders. But as Gabriela also mentioned, the idea is this is a first iteration, and we have taken on board so far the needs expressed. So indeed, if this is something that we see is needed, we could explore going into this direction. So thank you very much for sharing this with us.
May I add, if it's okay, when we have time?
Go ahead.
So I also chair a group called the Data Privacy Vocabularies and Controls Community Group. And within that group, we try to do similar taxonomies where we have techniques. So what you have as machine learning, we have as techniques. And then purpose is the application, for example, to use in immigration or other places. But between it, there is also the need to establish what the AI is actually doing in the use case. For example, image recognition, face recognition, and a lot more concepts. And for us, we require this in order to represent the high risk and the prohibited cases. So that was the origin of my question. So I will put the link in the chat for what we have. Yeah, thank you very much.
Okay, great. That's great. And also, if you have any comments, any questions, also any criticism, please feel free to share with us, because I mean that's we are always looking for feedback. And what we do, okay, the aim is to provide something that is useful and that corresponds to the needs of our stakeholders.
And we are also always open to align with existing other taxonomies. So I think it just enriches the data if we can also create further links. So that's very good to learn about also other existing resources. Yeah.
Hello, my name is Vladimir Alexiev. I'm from GraphWise, and I pasted the link here a couple of years ago through a European project called Enrich My Data. We assembled a taxonomy of AI-related concepts from Wikipedia. So we leverage the Wikipedia category structure, and we have a tool to prune and keep it focused. And it's about 7,500 concepts. I cannot say how clean they are. For example, until recently, we had in there the Shanghai Metro. Why? Because the Shanghai Metro turns out to have some automatic driving. I mean, without a driver, right? And because we also assume that anything that has to do with robotics must have AI inside. Of course, in a robot, you have many other things, but yeah, a self-driving train, I would say robotics is a main application of AI. Now, there is a data set, and there's also a white paper that describes a number of other thesauri that we looked at for AI-related terms. In particular, I would highly recommend the collaborative pattern classification, because it should be a starting point for defining thesaurus of applications of AI. I mean, over there you have very, very specific things about how particular type of machine learning network is used for this or that industrial control or map routing or self-navigation, or I mean, can't even think of all the different applications they have. I think we found something like 2,000 nodes in the CPC that are somehow related to machine learning or closely related areas. Of course, that is an ever-expanding domain, especially because of the boom of Gen AI.
Thank you very much. It's very informative and it's very good to learn about. Actually, the AI taxonomy has a quite limited scope, and especially it doesn't want to cover everything. So we don't want to be exhaustive because we know that it's also impossible in this very rapidly evolving field, but also because we wanted to focus on the European Commission and the applications that are using AI in the European Commission. So that's why it's really stated already in the scope of the taxonomy that it's very limited, and we don't aim to cover everything. But of course, for the alignment purposes, it's very good to have additional sources to align with. But we will not, of course, add everything that is probably not in the scope of the Commission. Yeah. But thank you, Vladimir.
I also have a comment about the ontology or the application profile. It's great that it refers to a number of prior efforts like OpenML and ML Sailor and so on and so forth. But I couldn't see an alignment file to say that such and such concept in the MLDCAT corresponds to such and such concept in the other. Maybe it just directly reuses URLs from those other ontologies.
We do use indeed directly URL from the other ontologies, Vladimir.
Okay.
And we try indeed, what we are trying to do is indeed showing in the reference where we reuse from. So at least we agree, let's say we have some reference. Yeah. I go next to the next point, which is to the pilot that we've done with the AI for EOSC, and I would like
Hello, I hope you can hear me because I'm seeing some network glitches. Is that okay? Okay. So it was Emilio, not me. So thank you for inviting us to this webinar. So first of all, let me briefly introduce the AI4EOS platform. We are AI4EOS is a Horizon Europe project in the research infrastructures topic that has finished in August this year. Our main aim is to develop a platform for building, sharing, and putting into production artificial intelligence and machine learning models for science and research in the context of the European Open Science Cloud. To this aim, we are developing a lot of stuff, but for the context of this webinar, we are developing a dashboard that the users utilize to enter into the platform, a link with a REST API that can be also consumed by the users or by the applications. So we got in touch with the SEMIC some time ago in order to run a pilot to improve our metadata and our metadata management tools to be able to publish a machine readable version of our metadata for the models, therefore improving the overall fairness and transparency of what users are doing in the platform. So basically, in this schema, you see what I just mentioned. The users via the web browsers can go to the dashboard and they can check our catalog, try a model, from the dashboard itself without modifying or without using any other tool. They can deploy a model for production, and they can get a code space where they can develop. This is linked obviously with an API where you can check the module metadata, you can get the list of tools that are available in the platform, you can manage your deployments or the tools. And with that, we are building our AI for EOS platform. So next slide, please. This is how it looks like. You can see at the left-hand side the dashboard that we are operating right now, where you can browse all the models with our own metadata schema that allows you to select it using the libraries that are being used for develop, the task that the model is aimed for, the platform category, so it is pre-trained or not. And on the right-hand side, you can see an individual rendering of a given module. In this case, for example, a module developed by the Karlsruhe Institute of Technology to detect thermal bridges on rooftops by using the drone images. So next slide, please. Since we already had some metadata in place that was based in JSON and a JSON schema that we enforced for the user, as I told you, we got in touch with the SEMIC and we started working together in improving this so that it could be mapped directly into MLDCAT-AP and hence getting let's say the interoperability almost for free with just minor modifications in our metadata. We decided that rather of modifying the metadata that the users are able to include in their models, because this is a very lightweight metadata that they can just fill in, we decide to do that on the platform level and expose this via the API. So we have our own metadata that is still being managed via YAML files that we're able to render into JSON. Then we transform it into a JSON LD response via the API that references the EOS MLDCAT AP context file that was prepared together with the SEMIC. That obviously imports the MLDCAT AP JSON LD definitions, and that way we are able to create this mapping without impacting the users. For us, it was important to do so because we think that, we think to an extent that end users should not deal with low-level details on how the metadata is handled, and therefore we are offering them just some fields that they can fill in, and we do all these transformations and enforcement of the different fields at the API level. So this is what I was mentioning. Via the API, you can still get our very own metadata schema, which is the EA for EOS and EA for OS metadata that is mostly equivalent to the JSON LD without modifications. And then you can select, depending on the profile that you can pass via query to the API and the content type, the access type that is sent with the request. You can get the MLDCAT AP profile that is rendered either in JSON LD or in RDF Tartan. So next slide, please. Once we have done so, we have moved from a simple metadata scheme that did not deal at all with linked data to a proper JSON LD metadata file that can be rendered in RDF, and where you can get all the relationships that the metadata and the MLDCAT-AP profile enforces. And I think this is our last slide, if I'm not mistaken. Yeah.
Yes.
I just want to highlight that for us, this has been a very productive collaboration and pilot, because as we were developing the platform, we realized that we were not semantic experts. We deal with a lot of technological aspects on training the models, on providing efficient access to resources, data access, and so on and so forth. But unfortunately, we were not we did not have in our consortium a real semantic expert. Therefore, for us, it was quite productive to engage with you, with the SEMIC, in order to bring this pilot, because I think that now we have achieved a good level of interoperability, and we know at least we have our roadmap for the next steps that are needed. So we appreciate very much this collaboration. Thank you.
Thank you, Alvaro. Indeed, now we pass to the last part of this webinar on some GitHub issues. We will not have the time to discuss them all, but we prepared them, so we can already discuss on them, one of them, and I think that was already where Arsh was going for. Indeed. One of the issues about the intended use, currently this property is indeed inside the machine model class as defined as a literal and cardinality 0, 1. Let's say in the issue, there are different points described. First of all, the definition is right now the objective or purpose of the model with the observation. So the IT 0, 1, so which implies the model more one, or at least at most one. With the issue, we'd like to propose to property in in the prescribed application of the model. So the way basically is intended to be used. We would like also, we appreciate to relax the cardinality. Relaxing is also quite good. However, we would like to have, at least for now, as literal, in the sense that the intention is to keep free text as taken from, as inspired from Hugging Face. For example, you see on the right-hand side an example of one of models, which is called Bloom, where the intended use, it's basically a free text and they intend to be used for that. So for now, the intention is at least changing the definition, because we agree that it's not clear, relax the cardinality, and for now we keep still literal, and then we will see this in a later stage. At least this was what we understood from Arsh on from the issue. If there's anything else, don't hesitate. Go ahead, please, Arsh. I stopped the video because my connection is not great.
Thank you, Emilio. So I sort of disagree that it should be a literal, because the intended use is a very broad concept, and within the intended use you can have many more granular concepts. For example, the purpose, the data, the user, the location, and so on. By keeping it as a literal, we basically have free text, which is completely impossible to analyze unless you use something which is non-semantic. So it is better to model it as a class and provide a property to describe the free text description, for example, using DCMI. And this is also the best practice in semantic web, so that in the future, if you decide to further refine the concept, it will not be backwards incompatible.
No, it's okay. If you, well, unless I have, there are other people in this community that also disagree, we could even change it as a class. What I would like to indeed having a common background, let's say a common understanding between us in this webinar. Because, first of all, as I said, the literal was inspired by Hugging Face, because we saw that people start to describe as a free text only. But indeed we could even review it, but then it means also some analysis is required to understand what in this intended use class should be, you see. So that's a second step. I see on one end Vladimir stating that on one end you could use the one from concept and as free text. maybe that could be a way. Definitely, I think this is what I understand, is that we need something that is more structured, at least. Not necessarily either as a class or as a concept, but I see the need. Yeah, thank you, Arsh. Okay, but what I would say then, we will look into make it as a class to see, at least to make it at least more structured. And so where we could put at least the part of the description in terms of the use of the description inside such class. Okay, that's at least for that. And then we see if we need to classify as a concept, as Vladimir suggested, as a concept on end on aside the free text. Thank you. We don't have a lot of time. Maybe we could go to the next issue and then we close with that part.
May I?
Yes.
Sorry,
Yes.
may I interrupt?
No problem.
Just a question here on this thing, and this is a very typical challenge we have to check whether or not the community is ready to supply something more structured. This is a lot of elements here to be provided, but if the community is not able to provide it in a structured way, then we try to do something structured, but we never are going to get it. So this is a bit of to the previous speaker, AI for EOSC. I don't know if they have intentions, and if their intentions are non-structured as well. Yeah, then making it structured will create just a blank notes all the time, and there's no value, and it's their community that has to change. So it's sometimes not the beauty of the wellness of or the correctness of the semantics in the sense that we have sometimes as well to know what is the state of capability of the ones who have to fill in the data. I just want to put that in the reflection to it, and I don't know. And
definitely, the idea is to start simple. You start simple because then, in that way, even many platforms that are able, let's say, they are not able to structure such data because it's not easy, of course. Then it helps when it's really, let's say, the data type it's not so structured. Of course, with if there is a need and if there are already models that express such need, then we try to be aligned with what we have, because indeed, as we said, we reuse other models like MLV, MLS, LPWC, and DPV. So these are the three models. We need to look at them to see if there is any already intended use property there, because we would like also to try to find a compromise between them. It's not always easy. But then, in any case, thank you, Ash, for this, because then we will look into it, and together with the observation from Vladimir, and then to see what we can do in terms of on this property. Definitely, we are going to change, as I said, the definition, the cardinality, and then we need to study how to make structure there. The intention is, again, we start simple, and then we iterate over time to see if we need more structure. Thank you, Bert. So one last issue maybe, and then we would like to close also on this, because otherwise we go over time. It's about the risk model. So inside the machine learning model, inside the MLDCAT-AP, we have a machine learning model with as associated 0 or multiple risk. So it's an optional class that is associated to machine learning model. However, the class indeed could be as it is, if you think about risk itself, could be indeed associated to other type of classes in the model. It could be associated with an agent algorithm. We need to consider that the definition of such a risk itself comes from the AI Act, Article 3 in this case, where is a combination of probability of an occurrence of harm and severity in the time. So we would like to keep such a definition because it indeed comes from the act and where it's risk associated with that. So the point here is if there is a need from the community here to express risk with other type of classes in the model. For example, from a data set or like I said, algorithm, do you need in this case to express such risk associated with other type of classes that you could see? Because so far that comes from the AI Act. Okay, we need to evaluate risk associated to machine model. So the relation is over there. But if you see that there is a need to add relation to it, please, we can let's say it now, or even continue on the issue 28 in this case, where the discussion can continue over there. So that is the part. For time being, we keep the risk as a definition because that is the one that comes from the Act, and for us it's important that we stick to the definition. However, if there are relations that can be created because there is a need from other type of let's say classes, like such as dataset, then we could talk about it, because in dataset we talk about also data quality, you see. And so I can imagine that risk could be maybe associated with it. But if there is really a need currently, let's say suggestions are more than welcome. So I think we can continue on the issue 28 of offline, I would say, towards using GitHub, the GitHub repository, and then we could move towards the end of this. There are, let's say, other type of issues which we already have some proposition. I'm talking about not only the risk model but also the elaborate splits, or even the use lang string instead of RDF's literal. So we already have some proposition for it, but there is no time to discuss for it. So we will propose having such proposition and continue on the respective GitHub issues. So what I would like is to close this part and discuss on the next step, which is basically release the MLDCAT-AP 3.0 in September 2025 with the resolution of a certain GitHub issue that we discussed today already, but also try to conclude on certain issue that we already analyzed. Contact us, please, if you want to have discuss for pilot opportunities, if you're interested. So it helps us also to review the model at the same time. That's basically feedback that comes back. And if you have any other feedback, still again using GitHub for any other point. I think I can maybe hand over to Natasha to close up the meeting.
Thank you, Mitio. Yes.
Yeah.
I would like to thank all the speakers we had today for this interesting webinar. Also, thank you all for joining. We are here if you want to reach out regarding pilots or questions or any proposals for enhancing MLDCAT-AP. And we'll keep you posted for any news and upcoming events. Thank you very much.
Yes, thank you. I see also other contributors like Daniel. Yeah, easy. Willem? No. I appreciate the contribution from Daniel Welter and the others that are indeed, this chat will be used as a part for us as an input for our work. This is what I just want to say. Willem, you want to talk? Maybe, no. No, but then thanks a lot to everybody for being part on this. And then we keep in touch along GitHub, so the work will continue indeed along this month in the new release. Thank you, Alvaro from EOSC and the DGP1 and the publication office to intervene into this webinar.
Thank you, Mitio.
Thank you.
Have a nice day.
Bye-bye.
Thank you. Bye.
Thank you.
Bye.
Thank you.